Salutations, splendid Swift students. This is Prof G, and we are about to finish our WordGarden app. You know how to do some of what we're going to do, so we will have two challenges to start. First, we'll have the all caps challenge to make sure that the user only enters capital letters, and then the sound challenge to add sound to gameplay. And then we'll learn how to perform very simple fade-in animations using UIView.transition. We'll also learn how to schedule code to run at a specific time using asyncAfter deadline. But there'll be no delay in our transition to big learning. Let's code! So first up is the all caps challenge. Now when we were laying out our interface, we set the capitalization attribute in our text field to all characters. And when we did that, the keyboard defaulted to caps lock on. But unfortunately, it's still possible to enter lowercase letters. Watch this example. All you have to do is click off the shift key, then you can type a lowercase letter. And that's not what we want in our game. We want all caps. Lowercase letters don't equal uppercase letters, so this could distort gameplay. But in an earlier video, you learned to deal with capitalization, so your challenge is to modify WordGarden so that any letter entered will be automatically converted to a capital letter. Feel free to refer to the earlier examples if you need them, but give this a try. So pause. Hopefully you can work this out, and let's resume and take a look at a solution. Now, in a previous video lesson, you learned about the uppercased method that can be applied to any string, and that takes everything that's inside of the string and converts it all to uppercase letters. Now, it's possible to apply this in a couple of places. One would be right here in our guessALetter function, right where we get the letter from our guessLetterTextField.text property. But this really isn't an ideal location, because if we were to put it right after guessLetterTextField.text! We'd take the letter that the user typed in and we'd uppercase it before we use it in our game. But we wouldn't change what the user sees in the text field, and it would be nice if we could go ahead and change that so it's all uppercase letters. A much better place for this is inside of our function guessLetterFieldChanged. Remember, this is an IB action that's tied to our text field, and whenever the contents of the text field changes, this function fires. Now, on the first line of this function, we get the last character that's entered in the text field. Well, if we put the dot uppercase open and close parens right after all of this, this whole line after the equal sign returns a string. Dot uppercased is a string method, so this is totally fine to do. You can chain the methods together like this, and this will work. So as soon as anything changes in that text field, our code will now look at it. If there is a last character, it will grab that character, and it will uppercase it, and it will put that character back into the text field. So if the user typed a lowercase letter, they're going to see an uppercase letter right away. Let's build and run and try this out. Here we go. I'll click on the text field. First responder, the keyboard shows up. Notice in the lower left-hand corner that the shift key is down, but also notice the user can tap on this and that turns off the shift key. Now the keyboard shows all lowercase letters, but watch what happens when I type this lowercase a. An uppercase letter A shows up. How come? Our IB action, that function, guessLetterFieldChanged, will run whenever there's a change in this text field. We grab the last character of the entry, we uppercase it, and then we put it back inside of sender.text, which is the text field that was changed. This works great. On to the next challenge. Now this next challenge is the Play Sounds challenge, and you already know how to play sounds. Now we copied over 4 sounds when we copied assets into the assets catalog in an earlier WordGarden lesson, and in this challenge, modify WordGarden so that when a correct guess is made, the correct sound plays, the sound incorrect plays for incorrect guesses, the word guessed sound plays after the player has successfully guessed a word, and the sound word not guessed plays if the user has used up all their chances to guess a word and they see flower 0, which is the wilty stem with no leaves. You can do it! Pause. You are skilled, you can conquer this challenge. Resume. Let's take a look at a solution. Now remember, when we work with audio, we've got to do an import at the top of our class, import AV Foundation. That gives us access to all of the data structures and methods that we need in order to play audio. Now we need one of those data structures right away, so down here in our class properties, we're going to declare an AV audio player. And we do that by typing var audio player, lower camel case, colon, AV audio player, exclamation point. And it's important that we declare this, but we not initialize it. Now let's go ahead and put our play sound code just before our IB actions. And you know what? You worked really hard developing that play sound routine back in your You Are Awesome app. Let's go ahead and use that code. We specifically wrote the code to be reusable. So I'm going to open up You Are Awesome. Here's my play sound function inside of viewcontroller.swift. I've got it highlighted. I'm going to copy it with a Command C. Then I'm going to head back to WordGarden. I'll paste in this bad boy. And we've got our sound set up. Now all we need to do is call play sound. Where are we going to call it? Well, whenever we have an incorrect guess, we display a new flower image. So how about we go right up to here, underneath where we have our flower image view.image updated, and we'll do a play sound, and we'll pass in incorrect as the name of the sound to play. Now, we previously didn't have an else clause in this if statement, and that's because if somebody guessed the word correctly, well, we don't need to change the image. But what we do want to do if they guess correctly is we want to play the sound. So we'll add an else clause with else, open and close curlies, and in there we'll call play sound and pass in the name correct. Now, when do we know if the user guessed the word correctly? Well, that's down here where we have our check win or lose if else if statement. And in the first part of the if statement, if it's true that the user has successfully guessed a word, right underneath where we increment word guessed count by 1, we'll say play sound, and then the name we'll pass in will be the string word-guessed. What about if they didn't guess the word? In the clause below that, right where we have word missed count incremented by 1, we'll call play sound and pass in word not guessed. Let's build and run and see how this sounds. No errors. Hammer time. Here's our app. Click in that text field. Let's type in an S and guess a letter. Whoop, my simulator keyboard popped away here, but I can still click on guess a letter, and how does that sound? Mellifluous! I think that sounds fantastic. S is correct. S shows up there. You get a sparkly fairy sound approving of your guess. Nice! What if we type in a letter that's not in there? We'll type in Q. Oh, and that's the sound of a leaf crumpling. Now, we don't have the animation yet. We'll do that next. And let me go through this just to guess a whole bunch of wrong letters so we can see what happens when we guess the word wrong. Here we go, moment of truth. Oh, and the sad word not guessed sound as we get the wilty image of our flower with no leaves. And what if we guess this right? What is this word? Cat? Nope. Oh, it's dog? All right, here we go. Moment of truth. Ho-ho! And you deserve that ta-da. Nice work, Swifter. Now let's spice up gameplay a little bit more with some transition animations. So there are a lot of ways to perform animations in iOS using Swift, and we're going to use very simple animations here, one which performs what's called a cross-dissolve, or a fade from one image to another. And to perform animations of this type, we're going to call UIView.transition. Now note that this is upper camel case here. That means this transition method is being called on the type UIView. Now it's less common to call methods on a full type name like you see it here, but we do so here. This is how animations work. Now we can use animations of this type on anything we see on the iOS screen. Things like buttons, labels, text field, images. That's because these are all based on the UIView blueprint, or the UIView class. Now, you'll learn the term subclassing later. Right now, note that the data structures for anything that you see on screen were initially based on or are subclassed from the UIView class. Now, one very handy thing about that is that anything that's a subclass of UIView gains capabilities of the UIView, and that includes these animations. So note that anything that we're learning here that applies to images can also be applied to buttons and labels and text views and anything else that you see on screen. Now we're going to call the version of UIView.transition with these arguments. So with is the view that we're transforming. In our example, it's where we're starting from, which is the flower image view. Now the duration is the length of time that it's going to take us to complete the transition animation to the end state. Or for us, how long is it going to take us to fade to the new image? So 0.5 here means that our animation is going to take half a second. This number is in seconds. Now for options, we're going to use the option .transition cross dissolve. Now there are a bunch of pre-designed transition types, lots of other different options too. You'll see a bunch of other options pop up in code completion. And I also encourage you to experiment with some of these on your own. There's a lot more to these options than we're covering here, but transition cross dissolve will do a simple fade. That's exactly what we want in this app. Now the animations argument is followed by curly braces, and inside of these is the end state of what we're transforming to. So if we start with what we have in width up here, we end up with what we've got inside the curly braces for animations. And we're going to take 0.5 seconds to get there, and the option that we're going to use to get there is the cross dissolve transition. Now what's this stuff at the end? Well, inside of this final set of curly braces can be any code we want to execute after the 0.5 second duration of our animation is done. In Swift, we refer to this as a completion handler. So when we've completed the code in the method, then we can go ahead and execute this extra little chunk of code right at the end. So that's pretty cool. As a parameter to the function, we're actually passing in additional code that runs after the function is done. And this function is going to be done after we're done with the 0.5 second duration animation. Let's use this in our code and learn some more. Now, inside of our guessALetter function, we currently have this block of code that handles updating the image that we have inside of our flower image view. And this block of code is about to get much larger. So why don't we create a function that's going to hold this new block of code? We'll define the function just above guessALetter. We'll call that func drawFlower and playSound. We'll put open and close parentheses for now, although we'll change that in a sec. Open and close curlies. And then let's go back down into our guessALetter function, highlight this block of code here that handles our image presentation. So that's if word guess contains all the way down through the else clause in that same if statement. Cut it out with the command X. We'll replace this code with a call to drawFlower and playSound. Then we'll head back up to our function drawFlower and playSound and paste in the code we just cut. And we're going to see some errors show up. Now, the reason for this error is because current letter guessed is defined as a constant down here in getALetter, and that means that this constant is local to just that function. So it can't exist. It doesn't have the scope that goes up to this other function here, drawFlower and playSound. We could create a class-wide property for this, but a better way to do this is just pass in the value that we want to use in the function. And to do that, in between the parentheses in the draw and play flower sound function, when I define it, I'm going to pass in a parameter. I'll call that current letter guessed, which is the same name that I have below. It could be whatever name I want to put in here, colon string, because that's the type of the value that we're passing in. Now, by adding a parameter, we've just changed the way the function is called, so we've got to go down and fix the call. But if we go down here into guessALetter, backspace over the drawFlower and playSound, and start to type it in again, Xcode already knows and shows us in code completion, hey, the version of this function now takes an argument. And for current letter guessed, we can pass in current letter guessed. Now I'm going to give myself a little bit of space here just below where we previously updated the flower image view. And in here, I'm going to call UIView, remember that's upper camel case, .transition. Now you get a couple of options in here, and we want to select this one. That's the transition that begins with. Code completion says it creates a transition animation for the specified container view. That's what we want. Press return. Now I'll space out these parameters just as I type. Xcode will eventually reformat these, but for width, this is going to be the UI view that we perform the animation on, and we want to be performing an animation on the flower image view, so we'll just put flower image view in here. Duration says time interval. That's how long this should take in seconds, so we'll put in 0.5. For options, I'm just going to type in a period, and remember I mentioned that there are a whole bunch of different options that you could use. Now some of these are other animations, curl up that looks like a page curl up, flip from bottom, left, right, top. Definitely explore these on your own, but what we want is this one transition cross dissolve, and we can see code completion describes that as a transition that dissolves from one view to the next. So press return to accept that. And then for animations, why don't we highlight what's in there, and we're going to put in open and close curly braces. Now inside the curly braces for animation, we put in the end state of what we want our view to look like after this half-a-second animation. So remember, we're animating with the flower image view. We want to show the wilt image for the number of wrong guesses. So what we'll put in here will be flower image view dot image equals UI image named, and then the string will be wilt string interp wrong guesses remaining. So again, to read the statement, we say, perform this UI image transition with the flower image view, take half a second to do it. The end state is going to put the new wilt image inside of our flower image view, and we want to use the transition cross dissolve to get there. iOS handles the entire animation. All we do is specify the view we're animating, the length of time, the animation type, and what we want things to look like when we're done animating. Awesome! Now this gray area after completion will allow me to put in the code that runs when the animation is completed, and I'll show you a trick that most developers use. Double-click on the gray area for the completion parameter, and you'll see that the method reformats. In this new format, we get a close parenthesis after the parameter just before the completion handler, and the completion handler is written in curlies that follow the method. Now this is actually a cleaner format. It's called the trailing closure format. Most people think that this is a clearer format because by breaking the completion handler off in a separate set of curlies, it sort of makes it clear visually that, hey, this stuff runs after the method above is completed. Now there's also a bool parameter that's passed to the closure. We're never going to use this, so we'll just put an underscore in here to ignore it. And for now, we'll just put a comment in between the closure curlies stating to do change to next flower number. And you'll see what I mean by that in just a minute. But let me first build and run, and I'm going to show you a common error that shows up. So we're getting an error here in between the curly braces for the animation. And by the way, when you have little chunks of code that are in between curly braces that are part of a parameter for a method, and that's what we have here with animations and our completion handler, those are referred to in Swift as closures. Now there are red error underlines under both flower image view and wrong guesses remaining. If you click on the little red error ball, you'll get a message that says that the property flower image view is in a closure and it requires an explicit self. Self in front of any class properties or functions of the class is something that Swift requires inside of closures. Now it's a weird syntax, but Swift requires this so that it knows where it can find the properties and functions. Self means look in the current class. In our case, it's in the current view controller. Now try not to be overwhelmed by this, because if you forget, Xcode is really good about identifying, hey, you need self here, and you can just click on the little buttons to fix this. That's what I'm going to do here. Xcode types the self in for me. I don't even have to touch the keyboard. I'll click on that error ball again. I've got to do the second fix, but things are looking good. Now I'll click on build and run. Here's our flower. I'll click in the text field. First I'll put in an S, which is a correct guess, and we play the little correct guess sound. But now let's put in an incorrect guess. I'll type in Z, and then before I press guess a letter, really watch what's going to happen in the area where the leaf will go away. You shouldn't see the brown leaf pop up immediately. You should see it transition to the brown leaf. It's going from one image to the other over the course of half a second. Let's click guess a letter, and we hear the crunchy sound, and look at that, we've got our brown leaf. Now, unfortunately, the leaf hasn't gone away. Now the image that you're looking at here is wilt 7, and what we want to do is, after we've done the transition to wilt 7, we want to show flower 7, because that will be the image that has the petal missing from the space where this petal is brown. Now how can we go ahead and immediately change the image so that it shows flower 7 after the animation is done? That's what the completion handler is for. Let's go back to our code and try this out. Now again, this set of curlies that follows the transition method above it is part of that method, but it's going to include a chunk of code that will only run after that method is done running, after the 0.5 seconds animation is done. We're ready to put some code in here, so I'm going to delete the to-do comment I put in here earlier. Now what do we want to happen here? It just so happens that the old line of code that we wrote to go from one flower image to another is exactly what we want to have in our completion handler. And we hadn't deleted that line of code yet, so I'm going to highlight that line right up here. This one here takes flower image view.image and it sets it to the UI image view flower, wrong guesses remaining. I'm going to copy it with a Command C. I'll paste it below. Actually, I should have cut it. We don't need this line up here, so I'm going to delete that. Now we're getting an error inside of our closure here. Can you guess what it is? It's because we don't have self in front of flower image view. I could have had Xcode type in the self dot right in here, but I'm going to go ahead and add them myself. We're also going to need self dot in front of wrong guesses remaining. Now let's build and run. We should have the animation working. As my first letter, I'm going to type in X. Let's see how this goes. Nice! A leaf crunches, we get our animation, and we end up with our flower image 7. Perfect! Let's guess a T. The correct guesses still work fine. Let's type in a Z. We spend half a second transitioning to wilt 6, and then right after that, immediately we show flower 6. Couple of more wrong guesses. Each of them animated with sound for crunchy goodness. Nice! Now, even though the animation takes half a second, we do start the animation right away. In fact, it starts while the keyboard is being dismissed. It might be nice if we could delay the animation to start just a little bit, just to make sure the keyboard has been fully dismissed before the animation happens so the user can see that half second of that leaf turning brown. Well, it is possible to delay an action in iOS with Swift. Let's take a look at how we might do that. The function is pretty straightforward. We just say DispatchQueue.main.asynchAfter, and we want to choose the option with deadline. Now the deadline is simply a time where iOS should run whatever code exists in the curlies that follow this statement. Now we might want to delay our animation for about 1/4 of a second, which is about the time it'll take to get rid of the keyboard. So if we use this statement down below, look how we calculate the deadline. We say .now, this actually gives us the current time, and by saying plus 0.25, it will run the code in the curlies that follow after 1/4 of a second. Let's give this a try. So back in our draw flower and play sound function, why don't we start entering this code just before we have the UIView.transition, and we'll eventually put that code inside of our dispatch queue. So give ourselves a little bit more space. We'll write DispatchQueue.main.asynchAfter, and the option that we want is this one that I've selected. So you can see that it's asyncAfter, there's a deadline, and then there's execute, but the execute is specifically followed by open and close parentheses, an arrow, and then void. Now what that means is we can put a code block afterward, and that's what's going to execute after the dispatch time. And we see the description in code completion refers to schedules a block of code for execution. So this is the one we want. Press return to select it. Now this execute parameter is a block of code. It's a closure, and we'll write it between curlies. And just like we did with the completion handler and our transition, I'm going to double click on this gray area here for the execute parameter, and we'll see that it reformats in the trailing closure format that most developers prefer. Then for our deadline, we'll put .now, and look at the code completion description for that. It says returns the current time, and then we'll just add 0.25. That's a quarter of a second. Then let's go down here and grab everything that follows the dispatch queue up until the else statement, cut it out with Command X, and paste it in between the dispatch queue curlies. Now if our code hits this line, it's going to wait a quarter of a second, and then it's going to run that animation for another half second. And you know what, just to make this a little bit more dramatic, we'll switch this back, but why don't we set, instead of adding a quarter of a second, why don't we add 3 seconds? This way we'll really notice the delay. Now if we build and run, we're going to get a couple of errors in here because we're inside of a closure and there's a class property that doesn't have self in front of it. That's flower image view. So we'll just add self dot in front of that. And we've got a function that doesn't have self in front of it. That's play sound. And we'll put a self dot in front of that. Now let's build and run, and let's put in an incorrect character. How about an X? Click done. We can count to 3. And there we go. The animation happens with a 3-second delay. Nice! So now that we have a demonstration of asyncAfter, let's move our 3-second delay back to a 0.25 second delay. You can do a quick build and run, type in the wrong letter, click done, and we get just enough of a delay for the keyboard to dismiss before the animation starts. Looking good. Now I'm going to keep going until we've made all of our wrong guesses and we've lost the game, because we're going to see that we've got a problem here. Listen to try to tell what's happening. So if you didn't catch that, feel free to rewind. What you heard was a quarter of a second of word not guessed playing. That was that really short whistle sound, and the reason why you only heard a little bit of this is after a quarter of a second, incorrect sound played. How come? Well, asyncAfter sets things up to play after a quarter of a second, but behind the scenes our code continues to run. The only stuff that's waiting a quarter of a second is the animation and the playing of incorrect sound. So because of that, we've got one sound stamping over the other sound. So what we want to do is, after we're done with the incorrect guess animation we have now, in the completion handler, we want to check to see if we're out of guesses, meaning wrong guesses remaining equals 0. And if that's the case, then since we're in the completion handler, we're done with the animation, and I chose a sound that runs as long as the animation does, so we can start playing the word not guessed sound. That's that whistle sound because you've lost the game. And then why don't we add another animation here as well? Since the empty stem shows up as flower 0, let's not just flash that on the screen at the end. Let's do another half-second animation so it sort of looks like the stem is wilting as we get to flower 0. That'll be a nice effect. Now, if we move the playing of the sound word incorrect guess, that whistle sound, inside of the completion handler, we want to make sure that we delete it from the place where it was currently called in our code. That's because it was starting early and then it was getting stamped on once our asyncAfter started. So let's code this up. So here I am in the completion handler for our UIView.transition. I'm going to make a little bit of space because we want to have an if statement in here. And I'll put in some comments that describe what we're going to do. So if we are not on the last flower, we should show the next flower. Otherwise, if we are on flower 0, we're going to play the sound word not guessed, that's our whistle, and we'll perform another UIView transition to flower 0. So even though we've got code and completion handlers and a delay in here, and then if-then logic inside of a completion handler, the logic is actually pretty straightforward. So what we're going to do here is say if self.wrong guesses remaining does not equal 0, open and close curlies, then we just want to show the next flower image, and the code to do that is this line right down here. So I'll highlight it, cut it out, and put it in between the curlies. Else, open and close curlies. Well, then this must mean that you're out of guesses. So what we want to do is we want to do self.playSound, and we'll pass in word not guessed as our string. And then under this, let's do another UIView.transition. And we'll choose this one with the with option here, and the setup will be almost identical to what we had up top. The with parameter is self.flowerImageView. Duration will be 0.5. Our options will be .transition cross dissolve, just like above. We'll put in curly braces for the animation. And you know what we're animating to is this same line above, where we set flower image view.image to the flower for the wrong guess remaining. It's just this goes in the animation, and we're going to take half a second to get there. So I'm going to highlight this statement here, Command C, just paste it between the animation curlies below. And we don't need a completion handler here, so we could just put in nil. Now let's make sure that we go down and find where we were doing a play sound of word not guessed. Here it is, right in the else if clause where we identified wrong guesses remaining equals 0. And let's make sure that we highlight and delete this, otherwise we'll still get the quarter-second whistle. So this should be good. Let's go ahead and build and run. And I'm going to race through 7 wrong guesses here and stop when I have 1 petal on my flower, and we'll see if we've solved our problem. So here we are. I'm about to enter 1 more wrong guess, and what we expect to see is we'll have a delay of 1/4 second where we don't do anything, and that's because of our asyncAfter. Then we'll begin a transition which is going to take 1/2 second. It'll turn this leaf brown. That actually transitions to leaf wilt 0. We'll be playing our incorrect sound during that time. That's our crunchy leaf rustling sound. Then, since our wrong guesses remaining is 0, we'll do another animation, this time to the little brown stem. That'll also take 1/2 second, and we'll play the word not guessed sound. That's our sad wilty whistle sound. And now it's the moment of truth. Let's see. Click that button. Perfect. Everything worked as we wanted. And let's just see how the results are if we guess correctly. D, O, and let's pause before G. Once again, the moment of truth. And we hear just the ta-da sound. And you'll notice we just heard the ta-da sound, which is the word guessed sound. We didn't hear the correct sound, which is that fairy sound. The correct sound isn't under a delay, so it starts to play, but then word guessed sound plays right over top of it, so we don't even hear that first correct sound. I think actually that's fine, but if you do want to fix that so that you hear that little fairy chime before you hear the ta-da, you know how to do it. Swifter, I think you've built a great app. I think you should feel really good about your skills. In this app, we covered so much ground. We worked with text fields, IB actions on text fields, the first responder, working with images of different sizes, all sorts of methods for working with strings, comparisons of strings, string manipulation, iterating through strings, working with optionals, force unwrapping, if, let, guard let, nil coalescing, optional chaining, the ternary operator, animations, and using asyncAfter to execute a block of code at a pre-scheduled time. That's a pretty impressive repertoire of skills, Swifter. I hope you're feeling good about your accomplishments. Remember, if you take a photo of work that you've done based on learning from this video series and tweet it out using the iOS Code Crush hashtag, you might be chosen in our weekly random drawing for the much coveted My Mac Builds Apps laptop sticker. Keep at it and put on some sunglasses. Your future's so bright, you gotta wear shades. Congratulations!